Welcome back, my friends, to tutormymath.com. My name is Darren, and this is Numbers for Algebra. Numbers for Algebra is a pre-algebra course specifically geared towards adults who are going back to school. Maybe it's been a few decades since the last time you took a math class. You need to build up those foundational math skills, understanding how numbers work before taking algebras. That's why we call it Numbers for Algebra. Last week, we had a lot of fun reviewing one of my favorite topics, which is the divisibility tricks, and specifically that divisibility trick for 9, for 3, and how to apply the tricks when we're looking at numbers like 6. And our goal is to understand this most important thing about numbers, this thing that mathematicians tell us is the most important fact that there is to know about numbers. We call it the fundamental theorem of arithmetic, and that is going to be our goal this week, is to understand what it says, why it's important, and how we can use it to understand everything from greatest common factor, least common multiple, square roots, fractions, multiplying fractions, adding fractions, dividing fractions, equivalent fractions, reducing fractions, converting fractions to decimals, percentages, all those good things in school that I didn't understand when I was in elementary school, high school. I didn't understand these things until I had the chance to go back and learn how numbers work. And that is what we're talking about here today. So, this week's little warm-up exercise activity, whatever you want to call it. How many numbers less than 100 are prime numbers? Prime numbers is something we spend a lot of time talking about and very much connected to this most important thing about numbers. So as a little warm-up here, take this list of numbers. If you want to write them out, you can, or you can check out tutormymath.com. You can download this file from there and print it out, or however you want to manipulate it. But we want to look at, we have the numbers 1 through 99. How many of these numbers are primes? Which ones are prime, and how do we determine it? And, obviously, if you're watching this, take a second, give it a go. Give yourself 5-10 minutes to really think through here. Which of these numbers listed are prime? How many numbers less than 100 are prime numbers? All right, let's go ahead and take a look. And what we're going to do, let's start with a few obvious ones that we know are prime, right? I think most people, most of the students that I've worked with, when you say, what is a prime number? They know, well, I think 2 is a prime number, 3 is a prime number, 5, 7, right? They recognize that these numbers are part of this sequence of prime numbers. But what exactly is a prime number? Well, a prime number is a number that has exactly 2 factors. When we say factors, we mean a number that divides into it evenly. So for example, the only numbers that divide 2 are 1 and 2, right? The number and itself is usually the more common way of saying it, but having exactly 2 factors. So 3 has exactly 2 factors, 5 has exactly 2 factors, 7, 1 and 7 are the only factors of 7. Is 1 a prime number? We sort of skipped it on the list here, and it turns out no. We do not consider 1 a prime number. Why is that? The only numbers that divide 1 are 1, and 1 is itself. But the reason we don't consider 1 prime is because it doesn't have exactly 2 factors. It only has 1 factor. We actually call 1 the unit. And when we get to this most important thing about numbers, these prime factorizations, there's a good reason why we don't want to include 1 as prime. So we can talk about that a little bit more. Now, we could go through and probably identify a few more that we just sort of know from that sequence. But let's actually take a slightly different approach here and look at which of these numbers are not prime? Which ones can we definitely rule out very easily as not being prime? Well, we might know that 2 is the only even prime number. Why is it that 2 is the only even prime number? Well, we know that any number that's even can be divided by 2 evenly and therefore has a factor of 2 and therefore can't be prime. And how do we identify an even number? We said the divisibility trick for 2 is you look at that very last digit, the ones place, and if it's a 0, a 2, a 4, a 6, or an 8, it's divisible by 2 and is therefore not going to be prime unless it's 2 itself. So right off the bat, we can go, well, actually, all of the numbers in this column here that end in a 2 are all even numbers. So except for 2, none of them can be prime. Same thing is true of all the numbers in the column that end with 4. They're all divisible by 2. Some of them are also divisible by 4. What was that divisibility trick for 4? Do we remember? How about the ones that end in 6? Definitely don't want to include those either. The ones that end in 8, we don't want to include those. And finally, the ones that end in 0. Anything that ends in 0 is not only divisible by 2, it's also divisible by 5, it's also divisible by 10. So right off the bat, we know that everything in that last column there has at least 3 factors, plus itself and any other factors that it might have. So everything that we've already sort of X'd off in red here, we know that these numbers are not going to be prime numbers. And actually, there's another column that we can eliminate here, which is the ones that end in 5. These, we can scratch these ones off as well, because we said the divisibility trick for 5 was that if it ends in a 0 or a 5, right? All multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 will always end in a 0 or a 5. And so none of them can be prime because they all have an additional factor of 5. So it's more than 2 factors because it's 1 itself and 5, and like 15 would have 3 as well, and other factors too. So now looking through our top row there, we've got 2, we've got 3, we've got 5, we've got 7. Hopefully we know that 9 is also not prime because 9 is 3 times 3. And we might know, actually, it's not too hard. Most people know that 11 is also prime. 13 is prime. We can sort of just start going through here. One pattern we might notice right off the bat is that except for 2 and 5, the only thing that a prime number can end in will be a 1, a 3, a 7, or a 9. That doesn't mean that all numbers that end in a 1, a 3, a 7, and 9 are prime, right? Because example, now 21, hopefully we know that 21 is 3 times 7. So just because it ends in a 1 doesn't make it prime. But looking at this second row here, we might actually think that because 11 is prime, 13 is prime, 17 is prime, and 19 is prime. And again, prime numbers will always end. They will always be odd numbers other than 2, right? 2 is the only even prime, and so all the other primes are odd. We just have to make sure that it ends in a 1, a 3, a 7, or a 9. And obviously, we don't include the odd numbers that end in a 5 because we know that they're multiples of 5.